Okay, we had some pretty interesting weather across parts of the country again last night and into this morning. We'll talk a little bit about that in our current weather discussion. Most of that interesting weather is associated with this cyclone that's over western New York State. The white lines here are sea level isobars. So, as we've been talking about in class, the pressure gradient force is a way to measure how intense is the contrast in pressure from one spot to the other. And that's instantly recognizable in a glance when you start to know about these things, as we've been talking about in class. The closer horizontally these white lines are spaced, the more intense is the horizontal pressure gradient force. And so we got a really intense horizontal pressure gradient force on the northern and western side of this cyclone, and actually also to the eastern side as well, but a little bit more intense to the northwestern side. So it's really windy over Lake Huron and parts of southwestern Ontario this morning as this storm goes across the region. And trailing to its south is a boundary that's known as a cold front, and we'll talk about this within the next couple of weeks in some detail. And along that cold front, there's a line of pretty intense thunderstorms, some of which have spawned tornadoes just to the southwest of Atlanta late last night and into the morning. And yesterday there were quite a bit of tornadic activity across the state of Alabama. We'll see some of that in the history of yesterday's weather in just a second. But this is an impressive cyclone. It'll present itself nicely on the satellite movie, and we'll start to talk more and more about the nature of these storms as we learn a little bit more in both today's lecture and then also the next lecture on Monday. All over the central United States, the pressure gradient force, the distance between consecutive or successive isobars, is considerably weaker across the western United States, and the weather is unsettled and not particularly well organized. And then well off the coast is a pretty big region of high pressure that's sitting off of the Pacific Northwest coast this morning. So let me show you the temperatures that go along with this map. This is from about 7:30 a.m. our time, local time, very warm in the southeast United States, in the 70s almost, from Pensacola, Florida, all the way to Raleigh, North Carolina, then some 60s along the coast, some 70s on the peninsula of Florida, so high 60s and 70s down across the south, and then considerably cooler as you move off to the north and west, and that's behind what we're talking about as a cold front. Remember, our cyclone center was here in western New York State, so the warm air is ushered poleward on winds from the south, because the flow is counterclockwise around the cyclone. So on its eastern side, the winds are coming generally from the south, and then colder air funneling in on the backside, the western side, and it leads us to a 32-degree temperature here in Madison this morning, quite a bit colder than what we've seen the last several, and will stay chilly for much of the day as a consequence of this circulation feature that's just off now to our east. And where it's warm, it's also very moist. Here are the dew point temperatures. 70-degree dew point in Miami. One of the first times we've seen that this year. 71 at Apalachicola. That's just miserably humid. I can't stand dew points above about 62. 670 is way too high for me. So widespread, very high water vapor content on the far eastern side of this cyclone, all ahead again of the surface cold front for reasons that will become clearer and clearer as we continue to go through the lecture series, and I'll highlight this also on weather maps. But it's really warm and moist everywhere along the eastern seaboard, and I'd say the Ohio River Valley. We're finally, when you get to southern Wisconsin, finally quite drier and colder. Although our relative humidity is high, the temperature's 32 and the dew point's 30, so we got a pretty high relative humidity. But and that probably is part of the reason why the clouds are going to linger for a while today. But very high dew points along the coast, and that's where some of the exciting weather has been as well. Okay, so let me show you now the. Oh, you know what I wanted to show you first, because we're just beginning to learn about this. Yeah, of course, I want to do this first. We just were talking about the geostrophic wind in the lecture on Wednesday. That is the wind that results from a balance between the pressure gradient force, which always points from high to low pressure perpendicular to the isobars, and the Coriolis force, which has to, if it's going to balance, it's got to be the same exact size, but in exactly opposite direction. And then remember, we were talking about how the moving object that generates that Coriolis force has to be moving at a right angle, such that the Coriolis force is acting at right angles to the right of that object in the northern hemisphere. So look at all these. I'm going to zoom in on the U.S. These black lines are the equivalent of isobars at a level about 3 miles or so above the ground, the so-called 500 millibar map. So we're on a pressure surface, but we're at about 3 miles above the ground, and these black lines are the equivalent of isobars at that level. And notice that where they are tightly spaced, the winds are quite strong. This little flag means 50 knots, and then every little bob next to it is 10 more. So this wind here, right off the Nanaimo, British Columbia, is 70 knots. The one here in Seattle or Aquila, Washington is 70 knots. The one down here in southern Oregon is more like 80 knots, so even stronger winds. And you notice that the winds that are strong with the little flags on them are in regions where the horizontal spacing of these black lines is quite large. Look at this in Spokane, where disappointment is about to ensue for Gonzaga fans. I hope I'm wrong about that. Anyway, very low winds, but look at the distance between between equivalent isobars. It suddenly gets really huge, the distance between these black lines. The consequence of that is the pressure gradient force is very much weaker there, and you don't need as large a Coriolis force, therefore, to balance that pressure gradient force. Consequently, the wind speeds, the motion of the objects, the air parcels, can be a lot smaller. And so you get really weak wind speeds in such regions. Here over us, actually, state of Iowa, parts of Nebraska, and South Dakota, winds are also weak. It's only 10 knots at Omaha, but that's because, again, the spacing between the equivalent isobars here is extremely large, which means the pressure gradient force is weak. If you go down here to Tennessee, look at how tightly spaced these lines are, and you've got a 90-knot wind roaring at 3 miles above the ground in Nashville. So it's a really nice example of the relationship between the wind speed and the intensity of the horizontal pressure contrast or pressure gradient force. Not only that, notice that since we're at 500 millibars, 3 miles above the ground, we're away from the friction layer. The wind has serious friction in it only near the boundary of the surface of the earth or near mountains. Sometimes over the Rocky Mountains you can get a little bit more friction even at 3 miles above the ground, but not over the plains. So look at this over Texas. Every one of these wind bobs, and this wind here near Del Rio, means that the wind is coming from the west-southwest. So it's blowing in that direction from Mexico into Texas. And notice how the wind arrow, the wind bob, is parallel to these isobars at every single one of these instances. It's really hard to find one. Here's one down near Cincinnati where it's a little bit across the isobar. That's rare, but that's because there's active weather there. In almost every other location, the wind direction is going to be just about parallel to the isobars. That is also a characteristic of the geostrophic wind. So here we are, 3 miles above the ground, away from the friction layer, and we're able to see the validity of this approximation that we make of the geostrophic wind. It's really a pretty good approximation for observing the actual winds at levels above the friction layer. And before we quit this map, I just want to show you, look at how there's undulations in the flow, broad scale undulations. They're not really closed off circular circulations the way we see on the surface maps. Instead, they're broad open waves. And that's going to have part of the story about how these cyclones and anticyclones develop. And we'll talk about that when we go a little further into the lecture series. But broadly speaking, over the North American continent, a broad upper trough, a little small scale trough over Missouri, Arkansas, and parts of Tennessee and Illinois. But the broad scale trough is over much of the country right now. And that is a word we'll start to use a little bit more as we move forward in our series of lectures. So let me show you now the satellite movie over the continental United States and adjacent water. So here's the cyclone of interest that is just now to our east, and it's kind of centered on western New York State. And notice along its southern periphery, some pretty exciting looking clouds developing right there across central Georgia and then into western South Carolina. Those carried some tornadic storms with them, and we'll see some evidence of that in just a minute. But this is a really intense convective outbreak that's going on, thunderstorm outbreak over Georgia and South Carolina right now. And that's the main storm in the United States. Here's the evidence of the unsettled but kind of widely and unorganized unsettled weather over the intermountain states. Notice the cloud top colors here are nowhere near as bright white as the ones over Georgia. These are deep clouds. The top of them are very cold. They're radiating at low temperatures. These are not so deep. And there's not much cloudiness immediately off the Pacific coast either, and that's a change from what we've seen the last several weeks. Here is a recount of yesterday's severe weather impacts across the United States. So every red dot represents a tornado. There were 23 tornado reports. Most of them, as you can see, were in the state of Alabama, around Birmingham and then off to the north and east of there. Some late last night, Greenwich time, were just to the southwest of Atlanta. Wind reports where the winds are greater than 35 knots are in blue, and they're quite a more widespread collection of them. And then hail reports are in green. There's hail all over the place as well. And the total storm reports were about 104 storm reports over this region of the country, just about where the Weather Service had put all the warnings out. Where you can see a few black triangles down here in Mississippi, a couple perhaps in Alabama. Those are hail reports of large hail, 2 inches in diameter or bigger. So those are scary. Those are bigger than golf balls. Okay, so that's gigantic bad weather. Okay, so let's look at the current radar that tells us the story right now across the continental United States. And as we can see, the western 2/3 of the country has little or no precipitation to discuss. Some associated with the northern and western portions of that cyclone, which is over western New York State, are quite evident moving into Canada. But here's the really interesting piece where we saw it just blow up in the satellite movie. Look at how much red and orange there is in that line of very intense thunderstorms going right across the central part of the state of Georgia. Atlanta's right here, so it's all south of Atlanta, but it's moving into western South Carolina. That's going to be a severe threat in all of these places during the day today, and that'll spread probably into North Carolina before the day is over. So it's really a wild day in a lot of places. Okay, and now let's take a look at our West Coast satellite image, and there's really one storm in the entire viewing area here that we can see. Nothing along the coast, but this really beautiful extratropical cyclone at about the date line. The date line is here. I guess it's actually about 170 degrees west. And you can see the obvious counterclockwise rotation of this massive storm, and the cloudiness is asymmetric. It's on the eastern side predominantly, a little bit on the western side, nothing on the southwestern side. And all of these different characteristics, we are coming within inches of talking about why they all behave this way. We will do some of that today in the lecture, and we'll do the rest of it on Monday. So we're going to really know about why these storms rotate in a counterclockwise fashion. And then a week or so from now, we'll learn about why the clouds have the distribution they do in these cyclones. So everything we've learned up to this point has prepared us for assembling it all into a really coherent description of the way these mid-latitude cyclones work. And so I'm quite happy to be at the precipice of beginning to deliver all of that to you in the lectures. And since it's Friday, let's take a quick look at our forecast temperature pattern for the next several days. This is a forecast made last night at midnight, and it's valid this morning at 7 a.m., and it's 850 millibars. The shading represents temperatures where they're kind of yellow and orange and red, it's warm, and where they're blue and purple, and then dark purple, blood red, they're cold. So here we are in Madison at 7 a.m. this morning, and we start out with a temperature of about -2 or -3 at a mile above the ground. And then consequently, it's about 0 C at the surface, 32 degrees. And we're going to just step forward 12 hours at a time. So this gets us now to tomorrow morning, slightly warmer by tomorrow morning in our location. See the X there, or the cross there is where Madison is approximately. And then a day later, this is Sunday, we get back to Sunday morning, we get back to about where we are now. The thing that's happened is a cyclone is kind of beginning to develop to our west, or to our east, I'm sorry. And that, just like today, is going to, by virtue of the counterclockwise flow around it, is going to, on the western side of the storm, drag cold air southward over us. And that is definitely what we'll begin to see as we move forward. This is now Sunday night, much colder over us, but even worse to our east in the wake of that cyclone. This is Monday morning where, wait a minute, what's all this warmth to our west? That's exciting. We have to see what's going to happen with that. And it does, in fact, move across us Monday afternoon and into the evening. But it's not a long residence time, because a really intense storm gets going on the southwestern shore of Hudson Bay, as you can see, with all the white lines. Those are equivalent isobars at a mile above the ground. That's a very intense cyclone. And for a while, we're on the warm side of it, all the way through Tuesday morning. But we don't stay on the warm side of it. As that thing races further and deepens further to the north and east, we eventually have the cold front pass through us late in the day Tuesday, and it's going to get considerably colder. This is much colder than right now by the time we get to Wednesday morning. And then it stays cold all day Wednesday, stays cold again through Thursday morning. Then a little bit of warming appears Thursday afternoon into Friday. And so Friday will be better than Wednesday and Thursday. And then by the time we get to Saturday, near the end of this forecast period, we're maybe just beginning to get a sense that we're going to warm up again into the beginning of the next week. So, and here's the evidence of that, quite warm over places to our west. So we have a period of a little bit of warmth on Tuesday, then a substantial cold shot on Wednesday and Thursday, and then a little bit of amelioration. You might notice, it's the last point I'll make, is that the area, the amount of cold air in the blood red that's to the north is getting smaller and smaller and smaller each week. And that's inevitable because the sun's up at very high latitudes. You just can't keep that air cold anymore like you could a month or 2 months ago. And so this might be one of the last really cool shots that we get for the whole cold season. So let's hope that's the case.